Today we're going to learn our last two exponent rules, which are the zero rule and the negative rule. We're going to start with the zero rule. If you look at the example on your screen that says 4 to the third over 4 to the third, this is actually a quotient problem because it's a division problem. And we know that when we have a division problem, we would subtract our exponents. So we would take this exponent of 3 and subtract this exponent of 3 from it. When we do 4 to the third over 4 to the third and we do 3 minus 3, we get 0. So we would have a base of 4 and an exponent of 0. But what does that equal? Well, let's talk about what 4 to the third over 4 to the third actually looks like. So when I have 4 to the third, that means 4 times itself 3 times. And when I do that over another 4 to the third, that's 3 more 4s being multiplied by themselves. Now, we've shown this before that every time we have 4 over 4, that's a 4 divided by 4, which is actually 1. So this makes 1, then this 4 over 4 makes 1, and then this 4 over 4 makes 1. Well, technically, I'm supposed to be multiplying all of those together. 1 times 1 times 1 is going to give me 1. So when I have 4 to the third over 4 to the third, that makes 4 to the 0. But that is always going to equal 1. So our rule for a 0 power is that any number raised to the 0 power is actually going to equal 1. So let's look at some examples. Our first one says x to the 0 power. Because x is being raised to the 0 power, that means that this has a value of 1. Our next one says x times y to the 0 power. Now, because this is a product that's inside of parentheses, everything in here is being raised to the 0 power. So technically, this is like me saying x to the 0 power, y to the 0 power. Well, I know that x to the 0 power is 1 because anything to the 0 power is 1. I know y to the 0 power is also 1. And because these were right next to each other, that actually meant that they were being multiplied. So it's 1 times 1, which is just 1. Now let's look at another one. This one says 3a to the 0 power. It's easy for us to look at this and say, oh, it's going to be 1. But that's not necessarily true. Because in this problem, this is saying 3 times a to the 0 power. So it's actually, if I write it out, it's saying 3 times a to the 0 power. Well, 3 doesn't have an exponent, which means there's an invisible exponent of 1. That means 3 is going to have to stay 3. But a is being raised to the 0 power. Again, anything raised to the 0 power is going to be 1. So this is like saying 3 times 1. And when I do 3 times 1, I get 3. So the value of this is equal to 3. Let's try this one. 5b to the third, c to the 0, d to the fourth. In this case, I have 5 times b to the third times c to the 0 times d to the fourth. Now, I can't do anything with 5, I can't do anything with b to the third, and I can't do anything with d to the fourth. But c to the 0 actually equals 1 because anything to the 0 power equals 1. So this is like me saying 5 times b to the third times 1 times d to the fourth. Well, if I had this problem, I would combine my 5 and 1 because they're whole numbers, and I would do 5 times 1 to get 5. Then I would have b to the third, d to the fourth, because I can't do anything with those. And this would be my solution. And if you notice from the beginning, all we've done really is sort of take away that c to the 0. Now let's look at the negative exponent rule. The negative exponent rule can be a little bit tricky, but we're going to look at what it means. So we're again going to look at it in terms of a quotient. So in this problem, we have 5 to the third being divided by 5 to the sixth. Again, we remember that if it's a quotient and they have like bases, like this one does, we would subtract their exponents. So I would do 3 minus 6 Well, 3 minus 6 is actually negative 3. So this is equal to 5 to the negative third power. So what is that answer? Well, let's look at it. If I have 5 to the third, that's 3 5s in my numerator. And then it's over 5 to the sixth. Well, that's 6 5s in my denominator. I know that every set of these is going to cancel and actually make 1. So these make 1, these make 1, and these make 1. And technically, I'm multiplying all of these ones. Well, if I have 1 times 1 times 1, that's just 1. And then in my denominator, I have 5 to the third. Now, if you notice, when it's written like this, I don't have a negative exponent. I should never have negative exponents in my expressions, and if I do, I have to change them to positive exponents. And the way we do that is by flipping these to their reciprocal. So technically, when we had this 5 to the negative third, we know that every number is always 1. So when we do a reciprocal, we flip. So once we flip, our exponent all of a sudden becomes positive. So this would be our simplified solution. So let's look at some examples. We have 4 to the negative fourth power. When we have a negative exponent, we know we never want a negative exponent, so we need to make it positive. Well, we can't just rewrite it as a positive number. What we're going to have to do is say, okay, I know that 4 is actually over 1, and I'm going to flip this number to its reciprocal, which means flip the fraction. So when I flip it, 1 is going to go into the numerator, and then 4 is going to go in the denominator. And as soon as we move this 4 down to the denominator, its exponent becomes positive. So this is my simplified solution. Let's look at our next problem. It says x to the sixth, y to the negative third, z to the second. Well, in this problem, again, these are all over 1, but here's where it can be a little bit confusing. X to the sixth does not have a negative exponent. So because that has a positive exponent, it needs to stay right where it is. So I would leave x to the sixth in the numerator. But y to the negative third does have a negative exponent. So to get rid of it, I'm going to take this and I'm going to flip it down to the denominator. As soon as I flip it down to the denominator, that exponent becomes positive. Now for z has a positive exponent of 2. So again, because it's positive, I'm not going to move it. It's going to stay in the numerator where it was. So now my expression is x to the sixth, z to the second, over y to the third. So whenever I have a negative exponent, I take the number, the base that has the negative exponent, and I flip it. If a number has a positive exponent and another number has a negative exponent, I only flip the one with the negative exponent. So let's look at a few more examples. In this problem, I have 7 to the fifth, x to the negative third, y to the negative fifth. So again, it's like this is over 1, even though we don't see it. So I have 7 to the fifth. Well, there's nothing wrong with that because that's a positive exponent. So I'm going to rewrite it and leave it exactly where it is, which is in my numerator. But then I have x to the negative third. Well, x to the negative third has a negative exponent, and I don't want a negative exponent. So to get rid of it, I'm going to move it down to the denominator. As soon as it moves down to the denominator, that exponent becomes positive. So now it's x to the positive third. I'm going to do the same thing with my y because I noticed that my y has a negative exponent of 5. So to get rid of the negative exponent, I'm going to flip it down to the denominator. And as soon as it flips down to the denominator, the exponent becomes positive. So my simplified solution is 7 to the fifth over x to the third, y to the fifth. And my last problem says 8 to the negative fourth, a to the negative third, b to the negative second. Again, all of this is over 1, even though we don't see it. Well, if I start with my 8 has a negative exponent of 4, which means I need to move it down to the denominator to get rid of it. So once I move it to the denominator, the exponent stays, but it becomes a positive 4 instead of negative. When I look at my a value, it also has a negative exponent. That means my a needs to flip down to the denominator. So a will come down to the denominator, and that makes its exponent positive. Then when I look at b also has a negative exponent, so it also needs to move to the denominator. And as soon as it moves, it has a positive exponent. But now I'm looking at this, and this doesn't quite look right, because when I have a fraction, I always need to have something in the numerator. In a problem like this, where I've gotten rid of everything that was in the numerator because it needed to move down to the denominator, I have to put something in the numerator. And what I'm going to do is take that 1 and I'm going to flip it up to the numerator. So my solution is going to be 1 over 8 to the 4th, a to the 3rd, b to the 2nd.